Hello, Algebra 2 students. Happy St. Patrick's Day. I'm sure y'all miss me so much, but the show must go on. We must continue to learn some math. I just made my first video for Algebra 1. Y'all, it is so weird teaching in front of my phone and not having students to interact with, so bear with me on that. And then I noticed I kind of have a lazy eye in the video, and I think it's because of this projector light. It really is kind of hitting that eye pretty hard. So I may look a little weird, and you can laugh at that, and that's okay. We're going to start with doing part 1 of 7.5. And so this lesson is all about graphing square root functions and cube root functions. But for part 1, we're just going to focus on just the square root functions, and then you'll have a homework assignment that goes along with that, okay? So we're going to start with this table of values. And by the way, you guys already, if you've picked up your math packets, then you have the blank set of notes. So follow along with me and write this down. I've already got this on your paper, so I've already picked some numbers that we're going to plug in, and we're going to plug it into this equation right here, the square root of x. And so we're going to use the middle part to actually show our work. So I'm just showing that I'm plugging those numbers into that function. So hopefully you are writing this down along with me. And so I've written all of that down in my middle column just to kind of show my work. And you may have kind of already figured out, wait a second, something doesn't look right, because I can't take the square root of a negative number. That's where those pesky i's come from. Remember those imaginary numbers. So what really happens here is that this doesn't work, and this doesn't work, and this doesn't work. So when we plugged in those numbers, we're not going to get an ordered pair. We're not going to get a point because we can't plug in a negative number, or we can't have a negative value underneath the radical. Remember, that's called the radicand. That's just whatever you have underneath the radical. That's what that's called. And so when our index, remember the index is the understood number right here. In this case, it's a 2 because it's a square root function. When it's even, we can't have a negative radicand. So now we're going to start with these numbers. The square root of 0 is 0. The square root of 1 is 1. The square root of 4 is 2. And the square root of 9 is 3. So we're going to plot and see what our graph looks like. Now don't forget, you want to always label your x-axis and your y-axis, especially when you're doing homework and you have to draw the coordinate plane. Please make sure that you're labeling those axes. I do take off points for that. And I'm going to plot the points that we have. So we didn't have any points from those first 3 numbers, but we do have 0, 0. We have 1, 1. We have 4, 2. And we have 9, 3. And you may be wondering, what is this graph looking like? Because it's really not like anything we've seen before. We're used to linear functions that give us lines. We're used to quadratic functions that give us parabolas. Remember, sometimes our parabolas open up, sometimes they open down. We worked a lot with polynomials where we would see things that look like an S or an N or a W or an M even. And this doesn't follow suit. So let's talk about what could happen. We already know that we were not allowed to plug in negative numbers. So this point right here, I'm just going to call it my starting point, because it's where the graph is officially starting, because I wasn't allowed to plug in any of those values prior to that. But we know that I could continue to plug in other numbers for x. Now you might be wondering, well, how did I know to pick those? Well, those were perfect squares. So for example, I'm probably not going to pick a 10 because the square root of 10 is not a perfect square. But I could pick a 16 because the square root of 16 is 4. Now this one's not going to fit on the graph that we have right here, but the idea is you could pick that number. I could pick a 25. I could pick a 36. So apparently what's happening is the graph is starting at our starting point, and then it's curving, and I'm going to draw an arrow to show that it's going to continue to go in that direction. Because remember, I could plug in a 16, I could plug in a 100, I could plug in a 400. I could continue to plug in numbers as x continues to get larger. And so that's what the graph of our square root function is going to look like. So let's talk about a couple things, because we have talked this year about domain and range. So let's talk about that again. Whenever I talk about domain, remember, domain is basically asking you, what is x allowed to be in this problem? Are there any restrictions? Is there anything that x can't be? Well, we already saw that x couldn't be negative numbers. So in other words, x in this problem was allowed to be 0 or any number bigger than 0. So my domain is x is greater than or equal to 0. And if you look at the graph, we can see that because our x values start at 0 and then our x values get bigger. There's nothing on this side of the graph at all. So it started at 0 and then our x values get bigger. Now let's talk about range. Remember, range is dealing with your y values. So it's talking about how high, how low is your graph going, what's going on up and down on the graph. Well, this point right here is clearly the lowest point on the graph, and it has a y value of 0. As my graph goes to the right, it also goes up. Notice your y values are becoming bigger. So my range would be y is greater than or equal to 0. I started here, and my graph is going up. Now it's not going up quickly, but it is going up, and so it continues to do that. So there we would have our domain and range. All right, so here we have what we like to call standard form, if you will, of a square root function, and it has some different variables in here. So it says h comma k is the starting point, which is exactly what we saw here a moment ago. For this particular problem, 0 comma 0, the origin, was our starting point. So it says h is the blank of what you see. H is going to be the opposite of what you see. In other words, if I see x plus 2, my h is not going to be a positive 2, it's going to be a negative 2 because that's the opposite of what I see. If I see x minus 5, my h is not going to be a negative 5, it's going to be the opposite of what I see, which is a positive 5. So h is always the opposite of what you see. But k is always exactly what you see. It doesn't change. If you see a plus 9, it's a positive 9. If you see a minus 5, it's a negative 5. So the value for k is always going to be exactly what you see. Now all a does really is a just kind of either stretches your graph or compresses your graph. So it takes those y values and it multiplies it. So it's either going to stretch it or compress it. But the h and the k are what you really want to identify because that's going to give you your starting point. And it's also going to tell you what you're going to start with in your table of values. And that is going to help us out. Other thing to note, it says make a table of values, which we just said. It says you want what's under the radical. Remember I used that word radicand earlier. So you want the radicand to be a perfect square. And remember we've talked about perfect squares. 0 is a perfect square. 1 is a perfect square. 4 is a perfect square. 9 is a perfect square. 16, 25. Those are all examples of perfect squares. So we want that value underneath the radical to represent a perfect square. Why? Because then we don't need a calculator. We can figure it out in our heads because we know what those perfect squares are equal to. So let's see if we can apply this. So as we look at this problem right here, it says graph the function below, then state the domain and range. So before we graph it, let's identify the h and the k. Remember the h is the opposite of what you see. I see a positive 1, that means my h is going to be a negative 1. K is always exactly what you see. I see a minus 3, that means that k is going to be a negative 3. Now if you ever get confused and say, well, how do I know which one is the h and which one is the k? The way I like to remember it is it's in alphabetical order. H comes before k in the alphabet, and h comes before k in this standard form. So that might help you out a little bit. Now the great thing about this is, number one, it gives us our starting point, but it also gives us our starting point in our table of values. So right here, I have negative 1, comma, I don't need to show my work, I already know that the y value is going to be negative 3. So our starting point is negative 1, comma, negative 3. That's going to be where we start in our table of values. It's also going to be where we start when we are graphing. Now we have to try to figure out what other numbers are we going to plug in, because remember we want what's under the radical to equal a perfect square. So I'm going to take that x plus 1 and I'm going to set it equal to some perfect squares so I can find out what x needs to be. Well, remember we already said 0 is a perfect square. Well, that happens when you have your starting point, so you don't need to worry about that one. So I'm going to set x plus 1 equal to the next perfect square, which is 1. I'm also going to set it equal to the next perfect square, which is 4. And lastly, I'm going to set it equal to the next one, which is 9. So I'm taking what's underneath the radical, and I'm going to set it equal to those perfect squares, and then I'm going to solve for x. So for this one, I get that x is -1. That's going to be, no, I'm just kidding. I did bad math. Silly me. That's 0. That's going to be the next number that we plug into our table of values. I'm going to subtract my 1 on each side here. I'm going to get a 3. So now I have another number to plug into the table of values. And then this last one, we're going to get an 8. And so that's how we determine what numbers we're going to plug in, as we want to get perfect squares. So in the middle, here's where I'm going to show my work. So I have the square root of 0 plus 1, and then behind it -3. This one I'm going to have the square root of 3 plus 1 minus 3. And then this one we're going to have the square root of 8 plus 1 minus 3. So let's do some math together. 0 plus 1 is 1, which is a perfect square. The square root of 1 is 1, and 1 minus 3 is -2. So there's my second ordered pair, 0, -2. The next one, we get a 4 underneath the radical. Well, the square root of 4 is 2, and then 2 minus 3 is -1. And then for our last one, we're going to get the square root of 9, which is 3, and 3 minus 3 is 0. So let's see how our graph looks. We're going to start at -1, -3. Don't forget about labeling your x-axis and your y-axis. So I've plotted that first starting point. Then I have 0, -2, 3, -1, and 8, 0. So we basically see the same graph we saw earlier, but it has been moved. It's shifted. We can actually say that it shifted 1 unit to the left, and then it went down 3 units. But the graph looks pretty similar. So let's talk about domain and range. Let's start with domain. Now the good thing is that you can look at your table and you can look at your graph and come up with that domain. If we look at our table, we started at -1, and then our x values got bigger. So I'm going to say x is greater than or equal to -1, because this is where I started, and then all of my other numbers that we plugged in were larger than that. We can also see that on the graph. X, this is as far left as the graph goes. It's at -1, and then our graph goes to the right, which means our x values are getting larger. Let's look at our y values, because that's where the range is going to come from. Our y values start at -3, and then they get
Attention,
bigger.
everyone.
Hold on.
We still have several chicken biscuits in the conference room in the cooler.
Anybody want a chicken biscuit?
Again, there's several chicken biscuits and orange juice and tea in the cooler in the conference room. Thanks.
Too bad y'all aren't here to enjoy that. All right, so if we look at our y values, we're starting at -3, and then our y values consistently get bigger. So we're going to write y is greater than or equal to -3. Again, we can see that in the picture. This is as low as our graph goes. It has a y value of -3. The rest of the graph is going up slowly, but it's going up, and so the y values are getting larger. All right, so let's take a look at this next one. We're going to start again by identifying the h and the k. The h is the opposite of what you see. I see a +3, that means my h is a -3. The k is exactly what you see. So I see a -4, so that means my k is a -4. So that's going to tell me my starting point for my table of values. So -3, -4. I don't need to show my work because I identified the h and the k. All right, remember, we're going to take what's underneath the radical, which is x plus 3, and we're going to set it equal to those perfect squares. So I'm going to set it equal to 1, I'm going to set it equal to 4, and I'm going to set it equal to 9, and then we're going to figure out what is x going to be. So I'm going to find out that x is negative 2, x is 1, and x is 6. So I need a negative 2, a 1, and a 6. So that's pretty easy to find out. Now we're going to plug it in. Now as you're plugging it in, look at your function, because notice you have a negative 3 that's in front of the radical. It's part of your function. So we're going to have negative 3 times the square root of negative 2 plus 3, and then behind that minus 4. Then the next one we have negative 3 times the square root of 1 plus 3 minus 4. And then the last one we have negative 3 times the square root of 6 plus 3 minus 4. So let's see what this looks like. If I start with what's underneath the radical, I'm going to get a positive 1, and the square root of 1 is 1. So now I need to multiply that negative 3 that was outside of the radical times 1, which is going to give me negative 3, and then negative 3 minus 4 is negative 7. So let's take a look at this next one. Keeping my negative 3, but let's do some math. 1 plus 3 is 4. The square root of 4 is 2. Now I need to take that 2 and multiply it times the negative 3, which gives me negative 6. And negative 6 minus 4 is negative 10. So last one, negative 3 times 6 plus 3 is 9. The square root of 9 is 3. So we're going to multiply negative 3 times 3, which is negative 9. And negative 9 minus 4 is negative 13. So I'm going to graph. Got to start by labeling my x-axis and my y-axis. My starting point is at negative 3, comma, negative 4. Then I have negative 2, comma, negative 7. So right away my graph's already looking different, because on the previous graphs it went up and to the right. This one is going to the right, but it's going down. Do you know what makes it go down? That negative out front. It's going to make this graph go down instead of going up. Then I have 1, comma, negative 10. And then lastly, I have 6, comma, negative 13, which is going off my graph a little bit. That's okay. So I'm going to start at my starting point and then curve it down and to the right. So let's talk domain and range. Again, you can go to your table. The table makes this really easy. Let's look at our x values. We started at negative 2, and then those values got bigger. So we're going to say x is greater than or equal to negative 2. Range, again, let's go to that table of values and see what's going on. Our y values started at negative 4, but this time they didn't get bigger, they got smaller. So we're going to say y is less than or equal to negative 4, because our y values got smaller. Alright, so I would encourage you at this point, this is the last example before this video is done, I would encourage you to pause it right here, try this one on your own, and then plug back in just a moment. So I'm going to give you a moment, pause it. Alright, I'm going to go ahead and get started with this one. So the h for this is positive 4 because it's the opposite of what I see. The k for this one is positive 1 because it's exactly what I see. So that tells me in my table of values that my starting point is 4, comma, 1. And I don't need to show my work. Alright, remember we're going to take what's underneath the radical and we're going to set it equal to those perfect squares of 1, 4, and 9. Because we need to find out what x is going to be in our table of values. So right up here, I'm going to do that. And a lot of you can do this step in your head, and you might not need to write it down. I'm going to find out that x can be 5, x can be 8, and x can be 13. So I need a 5, an 8, and a 13, and now I'm going to plug it in. Don't forget as you're plugging it in that you need that 2 out front. Okay, so here comes the math part. 5 minus 4 is 1. The square root of 1 is 1. So I'm going to have 2 times 1 plus 1. 2 times 1 is 2, and 2 plus 1 is 3. Next one, we get 8 minus 4, which is 4. The square root of 4 is 2. So we have 2 times 2 plus 1. Well, 2 times 2 is 4, and 4 plus 1 is 5. And then down here, 13 minus 4 is 9. The square root of 9 is 3. We're going to multiply the 2 and the 3 together to get 6. And 6 plus 1 is 7. So let's graph it, label your axes, see what our graph looks like. This number right here is positive. What do you think is going to happen to that graph? Is it going to go up or down? If you said up, you're right, because it's a positive value. So we're starting at 4, 1. Then we have 5, 3, 8, 5. Where am I? I did that one too high. Hold on. All right, 5, 3. Then 8, 5. That's looking better. And then 13, so I don't have enough room on your paper. You could probably have it out there. I'll just put it up here somewhere as far out as I can get it. So we're starting right there, and then we're going up and to the right. Again, remember, don't put an arrow here because it can't go past that starting point. And now we need to talk domain and range. Again, I really think the easiest thing is to look at your table of values. We started at 4, and our x values got bigger. So we're going to say x is greater than or equal to 4. Range, going back to my table of values to look at the y's. We started at 1, and then they consistently get bigger. So we're going to say y is greater than or equal to 1. All right, so that takes care of the video for this section. You have a worksheet to work on. It has 4 problems. So if you would work on those problems, make sure that you are showing your work in your table of values. I don't want to just see numbers. I want to see your work in the middle. And then I've also given you in that packet graph paper where you can graph it. Please make sure you're labeling that x-axis and the y-axis. You don't want to lose points for that. And then once you have that assignment done, if you'll take a picture of it and email it to me, I would appreciate it. And then you can get started on the video for part 2. Thank you.